you're looking at our title slide, and you see a bunch of icons and little, diagrams up there, and those kind of set the tone for what we're going to be covering and beyond. We're going to be talking about maintenance work order systems, which is more than what just the name implies. There's a lot to it. There's a lot you do with them. There's a lot of maintenance management that is incorporated in there, a lot of value. And we'll certainly take a good deep dive into these systems, because they're your one of the most important tools when it comes to plant maintenance engineering and maintenance management. And this topic that we're presenting to you today is sometimes referred to as facilities management. So if you've come across that term, that is basically same as what we're looking at here. Okay, so let's take a look at our list of topics. These are large, broad categories, so it's not a table of contents, so to speak. So we're going to take a deep dive into maintenance engineering and management. End up spending probably about 25–30% of our time in there, maybe even a little more. And then we will get into disciplines that are innate and vital in the performance of this function, maintenance engineering and management, such as electrical energy, electrical power, electrical controls, electrical safety devices. These are ubiquitous in any industrial, commercial facility, any processing plant. In many industrial, commercial facilities, electricity is perhaps it constitutes at least 50% of the total energy that is used. In many cases, it's closer to 70%. 70% of the energy we use, machines we operate, equipment we operate, or that functions in our facilities, whether they're industrial or commercial, it operates through electricity. So it behooves one to know just a little bit more about electricity, some of the very basic stuff that is important in understanding how you use electricity and how you pay for it, and and so forth. So we'll take a little bit of a intro of that. And but if you need to learn more about electricity, keep in mind we have a 2-day electrical engineering principle and concepts program designed mainly for non-electrical engineers. Occasionally we have electrical people attend as well, but and that we have one coming up on January the 10th, but the class is almost full. But I think there are a few slots left. But then beyond that, we'll have more of them, and we have some live that we're going to be doing up in the northern part of the U.S. So just go to our website and you'll see when it's offered if you are interested in expanding your knowledge in the electrical area, which is very, very vital when it comes to maintenance, engineering, and management. Then we'll get into plant engineering, project engineering and management. In a given plant, industrial, commercial setting, whatever, you typically will have plant engineering department. Sometimes plant engineering is part of maintenance, and sometimes maintenance engineering is part of plant engineering, and sometimes they're combined and referred to as enterprise excellence, which is a term that I kind of got familiarized with when I was in the corporate world for 34 years. And that's the term that was used in those departments that included plant project engineering or plant engineering, maintenance engineering, as well as even quality control. So sometimes all of those are lumped together under what's sometimes called enterprise excellence. And then we'll get into safety and industrial environment. Very important. As Sai indicated, that's an area of interest to him. We had a 8-hour program on safety a few weeks ago, and in that we took a deep dive into safety topics. Safety topics that would be of interest to engineers. So designed mainly with engineers in mind. However, we occasionally have non-engineers attend as well. They benefit just as well from safety program that we do over an 8-hour period. HVAC is another very extremely important component of plant engineering, plant maintenance, facilities management, and so forth. And by some accounts, something that we cover in our energy conservation program. We have a 2-day program coming up in New Jersey that'll be live face-to-face in second quarter next 2018. But anyway, in that program, we get deeper into HVAC controls. But HVAC consumes almost, as we cover in that program, consumes almost 70%, 60-70% of the energy in large commercial buildings, and somewhere to the tune of 40% of electrical energy in industrial plants. So, so pretty significant footprint as far as energy is concerned. As you know, HVAC has a very significant footprint, and and when we say that it has a significant footprint, means energy cost, is significantly a function of how efficiently you operate your HVAC system, how well you manage them. So we'll try to understand that, and not just from energy point of view, but from sustainability point of view. Sustainability, if you're not very familiar with it, is another term that is sometimes used for maintenance engineering and maintenance of equipment, plant equipment in general, and that's where the term sustainability comes in, meaning you're trying to sustain the operation of equipment in your facilities. And so clearly HVAC is a very important part of that. And so when, or you might say, when you think of HVAC, sustainability, or the continuous operation of proper operation of that equipment is very important. So therefore, sustainability of HVAC is important. We'll get into energy conservation as it pertains to plants, industrial plants, large commercial facilities. We'll take do a brief introduction of that, and as a part of that, we'll introduce you to EMS, BMS systems, which are another very vital tool that help you manage energy. In the absence of which, you're basically shooting in the dark, and not really hitting the target. You may end up spending 80% of your time and resources on 20% of the benefit, the old 20-80 or 80-20 rule. So so you don't want to do that, and EMS, BMS systems give you insight into where your energy is going, and so that you can target those areas and focus your time and effort and capital on those areas that where there is some low-hanging fruit. And then we'll get into renewable energy highlights. This is a brief excerpt out of our renewable energy program, which is a 1-day program as well. And through the renewable energy program, which we'll show you a brief excerpt of, we basically introduce you to some of the major renewable energy systems that are out there, that have, and most of our discussion in that program is about those renewable systems that are proven and have basically been scaled up. And then we also touch a little bit on some of those programs that might not be basically rolled out completely yet or scaled up yet, but are on their way and being proliferated and used more and more, and the economics, basically sometimes of those programs that are in their infancy, depends on how widespread their use is, and so as they get scaled up, they get more and more into the mainstream, but we give you a little introduction of that too. So anyway, when we finish towards the end of the program, we'll give you go through a list of these renewable programs, and that's about all we do. We don't really dive deep into any discussion on those particular areas. Okay, so that's the overall agenda for the day. Any questions? Any comments so far? Okay, all right, excellent. So let's go ahead and talk about maintenance, engineering, and management. And I'm getting just a little bit of noise from somebody, I'm not sure where, desk noise or something like that. So if you could keep your phones on mute if you expect noise in your area, certainly would appreciate that. All right, so within maintenance, engineering, and management, these are the topics we're going to talk about. We're going to talk about maintenance statistics. We're going to talk about recommended best practices for maintenance organizations. And, you know, these best practices are, you know, lessons learned out in the field in practice through, you know, real operation and actual immersion in these functions. And a lot of it is basically my experience when I was working as a maintenance engineer for, I'd say, 3 to 4 years in a large industrial plant. And I'll share some of those best practices with you and some others that we've, you know, picked from other sources. So, you know, I think you'll find a lot of this information quite helpful. It helps you bridge the gap, that gap that would be there, you know, unless you would immerse yourself in that function. So, so anyway, we'll get into that, and then we'll get into examples of computer-based work order systems. That's the tool to use these days. You know, gone are the days when, you know, work order systems were manual. Been there, done that, and cannot imagine ever going back to, you know, manual work order systems. Just like, you know, we can't imagine going back to snail mail, you know, and not having email and not being able to use email. So so just like that, you know, these the contemporary method for managing work orders and maintenance work is computer based. And you'll see there's a lot more to it that goes far beyond just managing work orders and adds a lot of value provided it's utilized and applied properly. We'll talk about maintenance personnel, leadership, and management skills. Again, you know, if you've not been in the trenches with maintenance folks, you may not be familiar with some of the stuff that we're going to share with you, some of the ideas and thoughts that we're going to share with you, some of the best practices that, you know, in my experience, you know, were proven to work. And so we'll share those with you. And then again, you know, if you've been in maintenance environment and you have, you know, also learned some best practices or or experienced them or whatever, and you'd like to share